So if you recall, in our last class, we talked about the flights listing app, the monolithic implementation of that. And one of the things we showed was a way of being able to go and find the best price for a bunch of airline flights. So assuming you want to fly a particular flight leg from one departure city to some arrival city, that app would go out and query databases and do some processing in order to figure out, among other things, what the best price was. And so what I'm going to do now is show you an interesting example, which is the EX34 example that you can find on my GitHub repository in the Java 8 folder that demonstrates various functional algorithms for finding all the minimum values in an unordered list. And I'm doing this mostly because it's kind of hard to find examples of how to do this if you take a look around in the programming literature and online. And there are going to be 3 different algorithms are going to be used to demonstrate how to find and print the cheapest flight or flights from a stream of available flights, which is part of this FLApp app that we've been taking a look at. So let's start off by kind of defining a few helpful fields here. We have this thing called a trip request. Here's what a trip request is. A trip request is just a data structure that defines a request for a trip. It keeps track of the departure, date and time, the return, date and time, the departure airport, the arrival airport, the currency that's being used, whether it be dollars or RMB or yen or euros and so on, and the number of passengers. And there's just a bunch of constructors and various methods here to do setting and getting of the various fields. I could have used some of the Lombok annotation features here, but I just wrote this out to avoid extra dependencies that we don't need to have for this simple example. So that's essentially the trip request. You can see here that this trip request is going to search for a flight that's going to be from January 1st, 2025 to January 2nd in 2025. So those are going to be the departure and return dates. We're going to leave out of this departure airport, which is London Heathrow Airport, and we're trying to go to the John F. Kennedy Airport in the US in New York, and we want to have the currency in euros, and we want to have a booking for 1 passenger. So that's just there so we can look something up in a little faux database and make the example interesting. Here's the main method. This shows how to print the cheapest flights using 3 different algorithms. The first one's going to be this one, the second one's going to be this one, and the third is going to be that one. And we'll walk through each of these and see how they differ. They're kind of cool. So here's the first method. This is called print cheapest flights min. And this is a so-called 2-pass algorithm that demonstrates a couple of interesting Java streams functional programming features, including min and filter. So here's what we do. We go ahead and we call this helper method called convert flight prices, passing in the currency type to convert to. If we go look at this method, this will convert the flight prices according to the relevant exchange rate. And you can see here we make ourselves a new exchange rate object. And then we go ahead and call this helper method called find flights, passing in the trip request, which is the trip we're trying to take. And what we get back from that, you'll see in a second. And then we go ahead and we convert the results by calling this convert currency method. Let's take a look at find flights first. So this method is in a little test driver class. We've got an array here that keeps all the flight information, departure and return times, and the airports and the price and the airline and the currency that they're in initially, and so on and so forth. And here's the find flights method. You can see here that what this does is takes the trip request, converts this array of flight information into a stream. So this is just basically an array of strings. We then go ahead and convert that stream of strings into a stream of flight objects. We do that using this little factory method here. And what this does is it splits the string by commas, and then it goes ahead and builds the appropriate flight object using all the various pieces. This is just low-level gobbledygook. I wouldn't think about it too much. It's just what you have to do. This simple example. If I had a database, it could be done much easier, but this is just for the testing purposes. So we end up with a stream of flight objects, and then we only keep flight objects that map the trip request. So of all the things there, we only get ones that actually map the flight legs that we're interested in here. So that gives us back a stream of flight objects. And you can see here, we take that stream of flight objects and then we convert the currency for each one, going from the to currency to the currency that we want to go to. Obviously, each of these flights knows the currency that they're currently in. And here's the convert currency method. We take the currency we want to convert to, the flight, and the exchange rate object. And if we need to do any conversion, obviously if the currencies are the same, we don't do anything. But if we have to do a conversion, we set the flight's price to be the current price times the exchange rate. Okay, so that's just kind of background. That's how we end up with a stream of flights that match the requests that are put into a consistent currency. And then up here, we collect this into a list. So we have a list of flights that match the requested trip leg. So now what we're going to do is we're going to take that flight list and we're going to turn it into a stream. So we have a stream of flights. And then we're going to use the min method. Now, the min method is an interesting method in a stream. What it's going to do is it's going to try to find the minimum element in that stream. And we use the comparing method here in order to be able to compare the elements in the stream by their price. So we're going to end up essentially finding the minimum price if there is one. If for some reason we had an empty stream, we would get back an empty optional. In this case, we don't have an empty stream, so we get back a non-empty optional. So we call the map method on the optional. We now get the min. And so then what we're going to do is for the min that we found, we're going to convert the list into a stream again. And then we're only going to allow flights that map the cheapest or the min price to make it through that particular stream. And if we get anything at all when we're all done, which we will, we go ahead and print the cheapest flights. Let me go ahead and run this program just so you can see what it does. So it's going to go ahead and start up, and it's going to go ahead and run all these different algorithms, and it'll all return, of course, the same results because they're always the same min for all the different types of algorithms. Okay, so that's the first solution. This approach, as you can see, if you're into algorithmic analysis, is going to be essentially linear time, but it's going to do two passes through the data. Does the first pass here in order to find the minimum price, and then it goes ahead and makes a second pass and finds everybody that matches that minimum price. So perhaps we can do better. So let's see if we can do better. So here's an alternative implementation. This implementation is going to, once again, convert the flights into the appropriate currency. And this time we're going to take everything that matches and we're going to sort them. And we're going to sort them so that the flights are now sorted from lowest to highest price. So we take all the flights, we go ahead and sort them, and then we collect it into a list. So we have a sorted list of results. Now, the list is sorted, so it's very clear what the lowest prices will be. They'll be the items starting at the beginning of the list. And so what we do here is we go ahead and store the cheapest price, assuming that there's a list that has more than one element, or more than 0 elements rather. So we get the cheapest price, which is the one at the front of the list. And then what we're going to do is we're going to use a very interesting intermediate operation called take while. And what take while does is it says, while there's something that matches the cheapest price, keep including that element in the stream that we're emitting. When we no longer get a match, when we find something that doesn't match the cheapest price, then we've obviously reached something that's not the cheapest price anymore. And so we will have ended up with a stream of elements that match the cheapest price. And we, of course, print all those things out. Now, if you take a look at this example, you can see that it's going to basically be n log n time to find the element and do the sorting. And then it'll basically take however long it takes to find the cheapest elements. So again, we're kind of taking, it's asymptotic time complexity is not bad, but we could do better. So the final approach we're going to do is we're going to use a one-pass algorithm and a custom Java Streams collector. And this is a particularly fun example because it demonstrates the power of using the Java Streams framework. So here you can see we go ahead and get the flight prices for the particular currency that we want. So we end up with a stream of all the matching flights that are for the flight leg we want in the right currency. And then all we do is we collect the results into essentially a list that will be a list that emits only the cheapest priced trips. And you'll see in a second how we do this. So this is just a one-pass algorithm, and it's very clever, very cool. And then, of course, we print the results out. So let's go ahead and take a look at the cheapest price collector. So here's the cheapest price collector. A collector is something you hopefully learned about when you took one of the earlier courses. If you took the software engineering course in this program, you should have been exposed to Java Streams. And so what we're going to talk about here are the features that are in the collector portion of this. And so you can see cheapest price collector is a collector. Collector is a Java framework mechanism that is parameterized by the type of elements in the stream, the type that's used to accumulate the elements, and then something that's called the result type. They end up being the same in this particular case. So cheapest price collector is a class that implements the collector interface. We'll see the methods it has to implement to be a collector here in a second. And we then go ahead and have a field called mmin, where that's just the current min value we've seen so far. We start out by setting it to the max value. So anything is going to be less than the max unless it's equal to the max. And then we have to define a bunch of overridden hook methods. The first one is called the supplier, and that is used by the Streams framework to create a new list implementation using an array list. So this is basically a factory method that returns an array list constructor reference, which is treated as a supplier by the framework. So that's what makes the accumulator that holds the partial results. Here's the accumulator method. This is a factory method that will return a flight. Actually, it's not a trip response. It's basically a flight into a mutable result container. And you can see here what we're going to do is it's going to say, if the price of the current flight we're looking at in the stream is less than the current min, clear out the lowest prices list, add the new flight to this now empty list, and update the min to be the price of this flight, because that's the current min at the moment. If instead the price of the flight equals the minimum, then we simply add that flight to the list. And if it's greater than the minimum, we just ignore it because it doesn't matter. So you can see here that this accumulator method is going to essentially replace the lowest prices array list whenever we've reached the point where we have a new min, and otherwise it's going to add the flight to the current list of lowest prices that we have. So that this particular approach is very nice because it does sort of the minimum amount of work. It pushes all the complexity into the collector rather than to the algorithm, and is arguably more efficient in terms of the running time. There's a thing called a combiner, which is used if we were to use a parallel stream. We're not using a parallel stream, but we still have to provide a combiner, and it just takes two lists and merges them together. We have a finisher, which is a no-op in this case because we don't use it. And then we have a characteristics factor method that indicates that we don't care the order of the results. And we also indicate identity finish, which just says the finisher can be a no-op. And then the last method we have here is the factory method that will create the cheapest price collector when the toList method is called. So that's basically this particular implementation. I just wanted to kind of show you how this worked because I think it's fun to see different ways of implementing the same algorithm using different functional programming features. So this approach uses Java collector. You can see it's very, very concise, pushes all the complexity into the collector. It's a one-pass algorithm. And then we have a couple of other kind of two-pass algorithms that use different features that we find with Java streams and functional programming in Java.